What you're seeing here is the setup for the next, I guess you could call, significant phase of building my Zenith 650, and that is getting the spars joined to the main spars joined to the center spar. So what you've got here is sort of a long view. Of course, you've got the center spar down here, and then I've got one half of the main spar up here. I have not seen much in the way of documentation on this part of the process of building an airplane, but of course it's sort of a critical part. I mean, how well you do this will affect the dihedral of the wing. And of course, if you get it wrong, then a lot of parts that I've spent a lot of time constructing suddenly become scrap. So this part of the whole process has been something that I've been sort of been on my mind quite a bit over the period of several years that I've been working on this airplane, and of course now I'm actually to that point. Of course, the good thing is that once I do successfully get through this, then I get to actually start making bigger pieces like wings and completing the fuselage. So what I'm going to do is cover some of the prep that I've done up to this point, just to provide some documentation for other builders that may be at a similar point in constructing an aircraft. And there will probably be, I don't know, at least one more and maybe two more parts to this as I go through the process. What I'm doing right now is essentially just test fit up. The second part would be I'll move this whole operation over to a building, another shop building with a little bit more space where I can lay everything out together and do the final alignment. Like I said, I don't have any intention of doing the drilling in here because I want to have both sides, both spars hooked up and all measurements done before I start drilling anything. So at the moment I'm shooting from on top of my table. I'll bring everything back down and go over a few of the features of what I've done here and how I've decided to approach this, and maybe some other builders may find this useful. So one of the first things I want to cover is just how I've got this supported. Of course, none of these parts are ever going to sit evenly or nicely on a floor or anything like that. So what I chose to do is to use 80-20 to support everything, which I found that fairly quite useful. I've actually used it in several other parts of the project, including supporting my main spar as I was doing my fit up for the ribs. Of course, 80-20 is a bit more expensive than wood. It's actually, I don't think it's too bad. Where they tend to really get you is on the fasteners. But generally, most of the fasteners are not that hard to make. A lot of the angle pieces like this, for example, I just made these up on my mill, for example. So a lot of the stuff you can make. There are a few things like some pivot points that I did go ahead and buy those, and of course they wanted $20 for each one of those, so it's a bit pricey. So just to provide a better idea of how I do have this all supported, we're taking a look at the bottom side of the center spar. Yeah, of course, this is basically just 10 series, 80-20, and then what I've got up here is a piece of, essentially it's 2-inch wide 10 series. But of course, there's not really much here in the way of level surfaces, but you do have a little bit of a surface right in here, so I cut some of this down to basically provide a support. And then I'm bumping my camera here. Of course, you can see some of the brackets that I constructed here, and then I used to do my leveling, I used what's called a lab jack. Let me grab one of those. And a lab jack, of course, is something normally you would see in like a chemistry lab, for example. But for this situation, it actually comes in quite handy. So if I need to get this leveled, it actually is quite capable of, if I need to adjust the height, I can provide some support to the, I can provide some support to this and be able to loosen these screws and then be able to adjust the height. Now, of course, they're not like super strong, but it's definitely more than adequate, and of course it actually has enough strength that it can actually pick that up. And of course I've got a similar setup for along the aileron, or for the main spar as well, just sort of try and show a little bit of a long shot of that. One other thing I wanted to point out, of course I ultimately wound up using the lab jacks, but one of the options for trying to lift things up so I could do adjustments was to look at what's commonly called an air shim. Essentially all this is just a little bag with sort of like a blood pressure cuff type pump on it, and you can squeeze that and of course it'll inflate the bag. Now for what I'm doing here, I found it more convenient to be able to use the lab jacks, but actually I can see this coming in quite handy in later stages of the building, especially for example the fuselage. Eventually I'll get to a point where I'm going to need to adjust it for level and such, and I think it'll using like these air shims will make it a lot easier to be able to do those kinds of adjustments. So I just figured I would just go ahead and mention that real quick in case that may be useful to somebody else. Now, as far as trying to figure out the exact dihedral itself, I don't know how well this will show up on the camera, but I've got a piece of fishing line. Essentially, I'm going to be using fishing line. So the reference point, as given in the Zenith plans, is actually at the top part of the spar. And essentially, what you're shooting for is approximately 17 inches. I think it's 17 inches of dihedral from the tip of the main spar to the top of this. So to do that measurement, really at this point I'm thinking the best way to do this is essentially just use fishing line. Now right now I have the fishing line set up on the bottom because I'm just sort of doing some initial evaluation, just trying to give myself an idea as to whether or not what all I've got set up here is going to work. But from what I can tell, basically fishing line will work just fine. As far as for measurement purposes, and trying to make sure especially that the dihedral is even between the left and right main spars. So one of the things that's I've really spent a lot of time thinking about in this in getting ready for drilling the main spar to the center spar is trying to figure out how I can ensure that I get these holes as square as possible. Now, of course, due to the size, there's no practical way to try and fit this in the drill press or the mill. And actually, I've tried it, and yeah, it was definitely too awkward, out of control. I would have wound up screwing something up. So I looked at a variety of drill jigs that are out there. Now, of course, they've got the I guess you could call it like a tilting type. That you primarily use for wood, and I've got one of those, but that's just too big and clunky, and this is sort of a tight area. So going back and sort of thinking on some of the various machinist tools that I've got, I finally hit up on a solution that I think that will work for me. And essentially, what I've got is a V-block, and then this is a piece of drill rod, and then this particular hole's been drilled out to 3/16. And of course what that does, of course V-block is a standard machinist tool, and I just bought this off of Amazon. So I mean, I haven't gone through and taken a measurement on my surface plate to be sure, but just a quick check of my square, I'm confident that this thing is square within 1/1000th of an inch. And of course, since you've got the V-slot here, if you go ahead and lay in a known round piece of stock, which I've got, this is some 3/4 inch drill rod that I've got, and I did some measurements, and it's well within 1/1000th of an inch of 3/4 of an inch. So of course when I put this inside the V, of course that guarantees that this is going to be in line. And of course I've got a lathe, and I went ahead and drilled a hole to fit my 5/16 or 3/16 drill bit for straightening out my 3/16 hole. Now the holes that I've already got here for the for drilling the spar in. Actually, these were sort of semi-guided because I hadn't thought of a good solution at the time. Some of it was done on the mill, but then some of it was also sort of hand drilled as I was enlarging it. And one technique I used at the time, and for some other areas, was to actually use the V-block itself as a guide. I hadn't thought of using setting up a drill guide like this. So now one thing you'll notice here, of course, I've got this clamped into the V-block. I've got a little gap down here to make sure that I've got room to be able to evacuate chips. And of course, all I need to do is just line this up on here, get the drill bit in, and get it carefully aligned. And of course, once this is on here, then I should be quite square. In fact, I've already done a few tests on a piece of aluminum that I've got, and over the distance of about 1.5 inches, I was within 0.4 of an inch of straight, which, I mean, in terms of machinist terms, it's not great accuracy. On the other hand, it actually wasn't a very square piece of aluminum either, but it's definitely enough to satisfy me that I think this technique will work. Now, of course, one problem you may run into, of course, this is sort of a small area and you've got to get your drill in here. So fortunately, V-blocks come in pairs, and my plan will be to secure this down and make sure it doesn't scoot around while I'm drilling, is just laying a piece of aluminum across here, and then just, you know, using the other V-block as a support, and then that'll give me enough room to be able to clamp back in this area and be able to try and ensure that this does not scoot around on me while I'm drilling. Now, one of the other advantages of going ahead and making everything out of the same stock material, 3/4 inch drill rod, is that I have made 3 more of these. I haven't drilled them out to size yet, but what I'll be able to do as I go through and start enlarging my holes, if this doesn't move, then I can just remove this pull this drill rod, swap in the next size, and I'll still be centered over my hole, and then I can go ahead and drill my, drill up to my next size. Now, the final size as specified by Zenith is 5/16 reamed. So, I mean, 2 of these I'll probably go up in 2 drill steps. I think this one is going to be 3/16, and I think this is 9/32. And then, I don't know, I haven't decided yet if I will ream this out, if I'll get this to 5/16 and then use the guide for the 5/16, or if I'll do that part freehand. I haven't decided yet. I've got to do a little more research to find out which is what's recommended as far as trying to guide reamers. So anyway, after really many, almost in a way, many years of sort of fussing over trying to figure out what would be my best option, I think this is going to work quite nicely. And I wish I've used V-blocks quite often as alignment guides when I'm drilling holes, but I'd never thought of doing this, and certainly wish I'd thought about it a lot sooner, because a lot of the other parts of my airplane where I've drilled would have definitely come out a lot straighter if I'd thought of this idea. So I think this is all that I'll cover at this point. Again, everything that I'm doing is just sort of prep work, investigation, trying to figure out the feasibility of different ideas for trying to maximize the chances of my successfully getting the this main spar drilled to the center spar. But there will be at least 1 and probably 2 more parts to this over the next, I don't know, probably couple of months. I'll spend a lot of time sort of fussing and thinking and testing before I actually go through and do the drilling for real. But as I make progress, probably when I get everything moved out to the big shop building and I've got everything laid out, I will do a quick update then, and I'll go into some more details of how I'm going to handle the alignment. Also, I've got to give a little thought to making sure nothing shifts around here. Of course, this is a pretty heavy piece of material. It probably won't scoot on me, especially once I have everything clamped down. But there's still definitely plenty of thinking to do here before I'm actually ready to start cutting metal for real. So that's all I've got for now, and if you've got any questions, definitely feel free to post a question in the comments.